Case study: Advancing Cybersecurity, TechSecure's integration of supervised learning for enhanced threat detection. The stakes in modern cybersecurity are higher than ever, and organizations are increasingly turning to supervised learning to enhance their threat detection capabilities. At the heart of this technological advancement is TechSecure, a cybersecurity firm led by Dr. Alice Thompson and her team of machine learning experts. TechSecure has been at the forefront of integrating supervised learning models into their cybersecurity operations, aiming to protect their clients from a range of cyber threats. TechSecure's first major project involved the development of a sophisticated malware detection system. Traditional signature-based detection methods were no longer sufficient due to the rapid proliferation of new malware variants. Dr. Thompson's team decided to leverage supervised learning to train their models on features extracted from known malware and benign software. They employed a deep learning model to analyze byte sequences and API calls inspired by the research of Raff et al., which had shown promising results in this area. One of the main challenges the team faced was selecting the appropriate features for their model. How should TechSecure prioritize and select features for their malware detection model? This question required the team to dive deep into existing literature and empirical data to identify the most indicative features of malware behavior. They eventually settled on a combination of byte sequence patterns, API call frequencies, and network traffic anomalies. This decision was guided by extensive feature importance analysis, which highlighted the attributes that most significantly impacted the model's predictions. TechSecure's model underwent rigorous training on a labeled dataset consisting of both malware and benign samples. The results were promising. The model achieved a high detection rate with minimal false positives. However, the rapidly evolving threat landscape necessitated continuous refinement. How can supervised learning models be adapted to evolving threats? The team addressed this by implementing a system for continuous learning. As new malware samples were identified, the dataset was updated and the model was retrained periodically to incorporate the latest threat information. This iterative process ensured that the model remained effective even as new malware variants emerged. The next challenge for TechSecure was enhancing their intrusion detection system. The KDD Cup 1999 dataset had been a benchmark for IDS research, facilitating numerous advancements in the field. Inspired by the study of Tavali et al., Dr. Thompson's team used the KDD dataset to train a decision tree classifier aimed at identifying network intrusions. Decision trees were chosen for their interpretability and efficiency in handling large datasets. During this phase, the team encountered the issue of imbalanced data, where malicious traffic patterns were significantly less frequent than normal traffic. What strategies can be employed to handle imbalanced datasets in supervised learning for IDS? The team experimented with several techniques, including oversampling and undersampling, as well as the use of ensemble methods like random forests to improve detection accuracy. They found that a combination of these strategies helped to mitigate the imbalance and enhance the model's ability to detect intrusions without generating excessive false alarms. Phishing attacks posed another significant challenge for TechSecure's clients. Dr. Thompson's team decided to train a supervised learning model to detect phishing attempts by leveraging features such as URL characteristics, email content, and sender information. The work of Basnet et al., which employed a random forest classifier to detect phishing websites, served as a valuable reference for their approach. One critical question was how to select and engineer features that effectively distinguish between legitimate and phishing emails. What are the key features that must be considered for effective phishing detection? The team identified several essential features, including the age of the domain, the presence of IP addresses in URLs, and the length of the URL. By incorporating these features into their model, they achieved high precision in identifying phishing attempts, significantly reducing the risk for their clients. Despite these successes, TechSecure was well aware of the challenges posed by adversarial attacks. Adversaries could potentially manipulate input data to deceive machine learning models, undermining their effectiveness. How can supervised learning models be protected against adversarial attacks? Drawing from the research of Papernaut et al., the team implemented adversarial training, which involved training the model on both clean and adversarial examples. This approach increased the model's robustness, making it more resilient against attempts to deceive it. Another critical consideration was the interpretability of the models. Complex models like deep neural networks often operated as black boxes, making it difficult for security professionals to understand their decision-making processes. How can the interpretability of supervised learning models be enhanced in the context of cybersecurity? The team adopted the Shapley Additive Explanations Framework, as introduced by Lundberg and Lee, to interpret the output of their models. Shap provided a unified approach to explain the predictions, enabling security professionals to trust and act on the model's insights more effectively. Deploying these models in real-time cybersecurity operations also presented challenges related to computational resources and latency. What optimization techniques can be used to ensure efficient real-time threat detection? The team explored various methods, including model pruning and quantization, to reduce the computational footprint of their deep learning models. They also leveraged specialized hardware like GPUs and TPUs to accelerate model training and inference, ensuring that their solutions could operate efficiently even under high data loads. The adaptability and continuous improvement of supervised learning models were crucial to TechSecure's success. As the threat landscape evolved, the team remained vigilant, continually updating their datasets and refining their models to address new challenges. What role does continuous learning play in maintaining the effectiveness of supervised learning models in cybersecurity? By adopting a proactive approach to model maintenance, the team ensured that their solutions remained relevant and effective in the face of emerging threats. In conclusion, TechSecure's journey in integrating supervised learning into their cybersecurity operations highlights the transformative potential of this approach. By leveraging labeled datasets, selecting appropriate features, and employing continuous learning, the team developed robust models capable of identifying and mitigating a wide range of cyber threats. Addressing challenges related to imbalanced data, adversarial attacks, and model interpretability further enhanced their solutions' effectiveness and reliability. As the cybersecurity landscape continues to evolve, supervised learning will undoubtedly play a pivotal role in safeguarding digital environments against ever-growing and sophisticated threats.